Okay, another early morning, day 6, advent of code. Let's check out what's in here. Tuning trouble. The preparations are finally complete. You and the elves leave camp. As you move through the dense underground. A handheld device. Has many fancy features, but the most important one, communication system. Okay, it's heard that you have significant experience dealing with signal-based system. Also, these are a lot of previous days interesting that we haven't done. He convinced the elves that it would be okay to give you their one malfunctioning device. Sure, you have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. The device needs to lock onto their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to the device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of a packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such 4 character marker. Okay, for example, this input. After the first 3 characters, there haven't been enough characters to find the marker. The first time a marker could have occurred is after the 4th character is received, making the most recent 4 characters. Because J is repeated, this isn't the marker. Okay. The first time a marker is after the 7th. 3, 4, 5, 6, 7. So here we have 4. Right, because then P. We have J and J still. P. Q, and then 4 unique. So after the 7th, 1, 2, 3, 4, 5, 6, 7, once it does, the last 4 characters received are JPQM, which are all different. In this case, your subroutine should report the value 7. Okay, interesting. So first, let's go ahead, as we always do, and generate day 6. And we're going to get this open. Here's our input, by the way. A long string. So what I'm thinking is we split each character, and then we go through and we can say const current 4 is an array. So I'm thinking we're going to keep pushing things into this array. We'll keep it at 4 characters all the time. And every time we'll run through the array and check if all the characters are equal. So let's start with the first part where we just fill this current 4 array up. So actually, if current 4 length is less than 4, then we're just gonna push line. This is actually not a line anymore. This is a character, right? keep forgetting this. This will be just an array of strings. And I'm going to play with a test input here. So this should be 10. We're going to do this. So if it's length, we just do that. Actually, maybe we can just push every character. If the length is now more than 4, maybe we need to shift. So that will keep it at length, and shift would return the first element. We push at the end. And then if it's more than 4 in there, we remove the first one. And then we need to go through all of them. Actually, we're going to need to break here at some point as well. So we're not gonna do these for each either. Okay, so let's rewrite that as well. So char of input array, and then this goes in here, and I think we just skip this, and we're gonna need something else to keep track of. We can call this index, and that's what we're gonna log here at the end. And we can say then sometimes in here we're gonna increase the index. Okay. So let's see, 6 and px node on number 129, because that's the length, but we need to figure out when to shift. So let's just see if this makes sense. We just want to shift if it's more than 4. We can do if current for length is above or equal to 4, or I mean, it's just going to be, it is going to be equal, right? In this case, we are const c of current 4 Oh, wait a minute. Could we do something like this? We use a set. Or set, new set. I guess iterable is going to be current 4. And then I think we can do, whoopsie. If for set length is 4. Actually, let's it's 6. All right. Right. I guess we can do that up here. 6. $10. Right, because we need to increase the index on every iteration. So I think this is going to be right. Here's our massive input, and our number is 1912. So let's try that. It's the right answer. Okay, so I think this is going to bite us now in part 2, but let's see. Your device communication system is correctly detecting packets, but still isn't working. It looks like it also needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of the start of message marker for all of the above example. So wouldn't we just, and just to keep this consistent, I'm going to run number 2 here. So change these to 14 and be done with it. Okay, so that didn't bite us. And it actually worked out very well, just looking for 14 characters now that were unique rather than 4. And I think the key here was using these sets, right? Because sets is similar to arrays. It's an iterable of stuff, but each item in the set is unique. So if you pass in an array and it contains duplicates, it's just going to filter those out. And then we use the set and we spread it, so we actually just get an array back. So if, for example, part 2 would have asked us, you know, what's the character where something happened, we wouldn't know that with this solution. But fortunately, we didn't need to do that. So that was day 6. I'm very happy. Today was took half an hour maybe, and part 2 was very simple. So that felt good, a little bit of a break. So let's see what happens tomorrow at day 7. Thank you so much for watching. Please like and subscribe the video if you enjoyed this, and I'll see you tomorrow. Thank you.